So good morning, everyone. Thank you for being here today. We will spend almost 1 hour together. The aim of this event is to share some knowledge and some of my experience on food packaging with you, and in particular on the concept of the sustainable food packaging. So I will give a 45 minutes presentation, more or less, and then I will leave 10 to 15 minutes for possible questions. And as I said before, I was thinking to activate your cameras and microphone to make the discussion easy. I'm Fabio Licciardello from the University of Modena and Reggio Emilia, part of the UNIgreen Alliance. Some of you already know me or my name because I'm honored to be the coordinator of the UNIgreen joint doctoral course, which has Unimore as administrative quarter, but is developed in partnership with the Polytechnic University of Coimbra, University of Almeria, University of Plovdiv, and the Agricultural University of Iceland. So today's lecture is about packaging-related strategies for addressing sustainability in the food chains. And I would like to present two key questions which will be developed in the next slides. So the first question I want to address is what is the role of packaging in the environmental performances of food products? And the second question is which packaging-related strategies can improve sustainability in the food chains? First of all, let me spend a few words on the concept of the sustainability, which I'm sure all of you already know. But I want to show these two alternative views of sustainability, which I like very much. In particular, the one on the right presents the three pillars of sustainability, so society, environment, and economy, at the same level, while the alternative view on the left side shows the environmental pillar as more important compared to society and economy. So this is probably, even if this representation is not very recent, I think it's very actual because it tells us that an environment which is suitable in suitable conditions, I mean, so that offers the conditions for society and economy development is fundamental. Also, the recent actuality and the history tells us that also political stability is a very fundamental pillar for sustainability, and is probably at the moment even more important than the environmental pillar. Anyway, all of these should be represented in the concept of sustainability. But today we will mainly focus on environmental sustainability linked to the food chains. About packaging, I want to briefly outline the main roles of packaging, and in particular of food packaging. Food packaging is essentially a container, so its basic function is to contain the food, but also to provide the conditions for the food distribution and transportation, so logistics. Packaging is also called the silent seller because it transfers information to the consumer and stimulates purchases. Packaging also offers convenience, so some of the functions of packaging are to make the use of the product easier, or the reuse or reopening or closure easier. But probably the most important function of food packaging is the protection of food. So packaging is not just a container, but a protection. which means that the packaging is an essential tool for guaranteeing a certain shelf life for the product. So if we want to protect our product and provide a certain shelf life, we have to choose the right packaging with the right performances. And last but not least, the environmental function. So packaging is, of course, has the responsibility to protect the environment, even if sometimes this is not correctly done. But this is not a matter or a responsibility of the packaging itself, but of course it's a problem of management of the post-consumer packaging. Environmental sustainability has been and is usually a driver for innovation in the packaging sector. And I want to show you a picture here, which is probably the highlight of my presentation. I'm very proud of this picture, which was kindly supplied by my mother. This picture is from my 10th birthday, and it shows happy children with a cake and some bottles. So this is the reason why I asked my mother to scan this picture and send it to me, because I wanted to show to my students an example of how the bottle for carbonated soft drinks evolved during the years, or in the last years, last decades. And so this picture shows a bottle of Sprite as it was in the late 80s. And here you can see how it became in the today times. So Fanta in this case in the 80s, and then in the in the last years after the 90s. Yeah, in the 1990s something happened, and a new design for carbonated soft drink bottles was implemented, and in particular this design included self-standing bottom, which is called a petaloid bottom, which has the shape because it has the shape of a flower, as you can see here. And the reason why this bottle design was changed can be linked to environmental sustainability issues. So the former bottle was made of two different materials. The main body, which was a PET, as it is today, and then there was a bottom, since the main body had a round shape and couldn't self-stand. So it needed a bottom which had the shape of a cup that had to be glued to the bottom to allow the bottle to stand. So this was a problem under two perspectives. One was the complexity of the bottle, so making a bottle with two different materials and then collect separately and manage these two materials in the end of life. And then there was a technical problem, which I remember very well, and probably some of you attending the seminar. Sometimes when the bottle went through temperature shifts, so from the fridge to outside the fridge and again in the fridge, the glue lost its function, and the bottom could be detached, causing the bottle to fall. So now we have this beautiful bottle, which is self-standing, and it optimizes the material, the plastic material use, and it's 100% recyclable. Another example of how environmental sustainability has driven innovation in the food packaging sector is again within the beverage sector, but this time I want to present the evolution of aluminum cans. This is how the can appears today, but in the 60s, 70s, and 80s, the can had a pull tab which was then changed in the 90s with a stay-on tab. So today we open the cans with this stay-on tab, which allows the small part of aluminum to remain attached to the main body of the can. So this transition to the new model was again stimulated by the need to avoid that the tab became a litter. Usually people open the cans and threw this pull tab away, often littering the environment or causing some injuries on the beaches. So this became the standard opening for cans in the 90s and allowed to recover 100% of aluminum, which is, by the way, quite expensive material. So it's not just a matter of environmental sustainability, but also optimization of costs. And another example, but please pay attention to this example, is PLA, so polylactic acid, which can be used to make bottles. This slide tells us about environmental sustainability as a driver, but I'm not quite, I don't quite agree with this time, so I will explain later why I don't agree in this case with this link. And I prefer to say that this is an example of how marketing can be a driver for innovation in the packaging sector, even if we are talking about green technology, which is the use of bioplastics. So please be patient, because in the last part of the presentation, I will explain you more about this. Well, it is my opinion, supported by scientific evidence, of course. Sorry, okay, here. Yeah, environmental sustainability is also a driver for legislation. And recently we had some examples on about how environmental sustainability has changed and has guided our EU legislation. One example is the EU directive, so-called SUP directive. SUP stands for single-use plastics. This directive targets the reduction of the impact of certain plastic products on the environment. And one of the most popular measures, popular because many people have discussed about this, but probably not popular in terms of acceptance. No? Many people have criticized this measure. The so-called tethered cap on bottles and on cartons, so beverage containers in general. Starting from July 2024, all beverage containers must have a tethered cap, so a cap which stays attached to the main body of the container. And this measure was implemented with the aim, the purpose of trying to reduce the dispersion of these caps, not only in the environment, but also in the collection streams of post-consumer packaging. Because small items in general, such as cups, are not easy to be managed and collected in the streams. So if we guarantee that the cup remains attached to the bottle, the two items will follow the virtuous flow of collection and then recycling process. Another example, sorry, okay, on how environmental sustainability has guided EU legislation on packaging is more recent and comes in the last 2 or 3 years. Starting some data, which I show here. So the European Commission estimated the packaging waste per person in 2018, accounting for more than 175 kilograms of packaging waste per capita. This value was much higher than the value recorded in 2006, which was around 150 kilograms, and is forecasted to continue to increase until 2030, surpassing 210 kilograms per capita, with a business as usual model. So this means that the European Commission thought that if we continue to consume like this, as we did until today, the packaging waste amount will continue to grow, and we need to reduce, of course, these wastes. So the option number 2, 2030 option 2, shows a possible decrease by 5% of the packaging waste per capita. And this will be possible by implementing the measures proposed or imposed by the PPWR, which is the Packaging and Packaging Waste Regulation, which is today the regulation number 2025-40 of the European Parliament and of the Council on packaging and packaging waste. So this is the most recent regulation, which caused some discussion also among, of course, among food companies, because it will oblige the companies to take strict measures to achieve some specific targets. So this regulation sets targets for the reuse of packaging and for minimum post-consumer recycled content in plastic packaging. In particular, at least 25% of recycled content in bottles by 2025 and 30% increasing in years. So 30% by 2030. So this means that bottles already today have a minimum 25% content of recycled plastic, and this amount will continue to grow necessarily. So this will allow overall a decrease in the packaging waste per capita. So going back to the first question, what is the role of packaging in the environmental performances of food products? I want to show here two different perspectives coming from literature. One saying that the significance of packaging production and post-consumer life on environmental impact is low and represents from 1 to 10% of the total environmental impact generated by the food chains. But other researchers in the same period, more or less 1 year later, say that the impacts of the packaging material life cycle are very often among the most relevant environmental burdens. So these very, very different opinions leave us leave the question open. So a few years ago, starting from these different opinions, I wanted to address the problem and proposed this synthetic parameter, which is the packaging relative environmental impact, with the acronym of PREI, which is simply the ratio, the balance between the environmental impact of the packaging and the environmental impact of the food, taking the global warming potential as a generic indicator of environmental impact. Of course, this is a simplification, but it's also a very agile and easy to manage tool, because starting from data, from literature data, we can make this assessment. PREI is a balance between the actual environmental load of packaging and that of a specific food product. So it can be used as a tool, as I will do in the next slides, as a tool to support improvement strategies. And PREI is also an estimate of the influence of food waste on the overall environmental performances of food systems. Because when we see that the environmental impact of food is prevalent, so we have a low PREI, it means that we should address measures that allow to save food. Otherwise, we will cause unnecessary impacts caused by the food wastage. Similarly, in 2019, Heller and colleagues proposed the food to packaging indicator, which is exactly the opposite. So it's the inverse ratio between the environmental impact of the food to the environmental impact of packaging. So it gives the same information, but of course it has to be considered in the inverse way compared to PREI. So to give you an example on how to use PREI and which kind of information PREI can give us, I want to show you this graph, which I published together with Professor Pier Giovanni in a book chapter in 2021, showing different PREI values for different product categories. So we have products on the left side of the graph with a very low PREI, because these products are characterized by a high environmental impact, high global warming potential, referred to the food production and processing, so the raw material production and processing. And then on the right side of the graph, we have products with the high or very high PREI, that are products for which the packaging material impacts much more than the food. So here we have beverages such as beer or carbonated soft drinks, CSD, wine, or products packed in metal, such as canned tuna or carbonated soft drinks in aluminum. So this is, as I said, PREI is a tool, or can be used as a tool to address specific improvement measures. In particular, if we look at the right part of the graph, so we take into consideration high or very high PREI products, the actions that can significantly improve the environmental performance of the system are actions aimed at reducing the impact of the packaging. So this means using packaging with a lower weight, so lightweighting the packaging, or recycled content, reuse, or in some cases, possibly the use of alternative materials. For example, glass for wine and beer has a very high impact, even if we are probably used to thinking that packaging or plastic packaging is the kind of packaging that impacts most. Scientific data and evidence shows that it's actually glass and metal that impact more, due to the very high energetic requirements of the production of bottles and cans. So actions aimed at reducing the impact of packaging. In the case of low PREI products, on the other hand, we should address actions aimed at reducing food wastage. As I said before, when we have a low PREI, it means that it's the food that is the real hotspot for the system. So we should try to either reduce the impact of the food production, if possible, or avoid food wastage, because food wastage turns into an unnecessary environmental impact. A very beautiful study, interesting study that I always cite is from the Swedish colleagues, Wilkström and colleagues, from 2019. Synthetically, this graph, which I reproduced from the study by Wilkström and colleagues, shows that different product categories have similar balance between the environmental impact of the food, of the wasted food, and of the packaging. So, of course, the food that is actually consumed is linked to the highest impacts. Then the wasted food has a very significant impact, but the packaging at last is the least significant impact for both food categories that were considered. So this is very important because this recalls us that packaging is actually not such a meaningful burden compared to the wasted food. So it is more reasonable to address the problem of food wastage instead of the problem of the packaging, which, on the other hand, can save food. So going back to the question number 1, I want to give you now a first output of our discussion. What is the role of packaging in the environmental performances of food products? So the answer is it depends. Sorry, I cannot give you a definitive answer, but of course the answer is it depends. It depends on the kind of product we are considering, because packaging may have a negligible impact while being essential for preventing unnecessary impacts, that is food wastage, or packaging may represent the environmental hotspot. So if we think at the graph, products which have a very high prey, so on the right side of the graph. So starting from prey, so from the awareness on the specific role that packaging has on the specific food category, we can propose measures that save food, in particular for products with a low prey, so products where packaging impacts very little compared to the food production and food processing. In this case, measures that save food will improve sustainability of the food chain. So we have different evidence that I want to show now. One is from a research group of the University of Milan. It's a case study carried out on beef meat. And the conclusion of the study is that when food waste effect is considered, the best environmental packaging solution for beef meat is the one that determines the longest shelf life. So I think the real novelty of this work was to finally manage to link shelf life and food wastage with the environmental performance of packaging solutions, because this is quite rare. No one did this before, and usually we have an environmental assessment of packaging materials, of distribution, of any kind of aspects implied in the life cycle of the product, but not considering food wastage. Other two statements that I want to report as are packaging solutions that minimize the generation of wastes at household and or distribution and retail level lead to the lowest environmental impact of the entire product packaging chain. And then it can be environmentally reasonable to increase the impact of packaging when new packaging design helps to reduce food losses. Again, these two statements are very original, I would say, and in particular, it says this says the opposite compared to what consumers usually think. So we should minimize packaging because packaging is an environmental problem. These statements, based on scientific evidence, tell us that it is reasonable to increase the impact of packaging if this leads to reduced food losses. So if we want to improve the protection, so the functionality of packaging in view of a reduction of food losses, we can propose active packaging, which is a tool, a strategy for attributing new functions to the packaging, such as antimicrobial or antioxidant functions. An active packaging may release in a controlled way active compounds, such as an antimicrobial, such like in this case, the case I'm showing now, we use the LAI. This is an ethyl lauryl arginate used as an antimicrobial active compound, which was incorporated in bioplastic cups. And as you can see in the image on the left side, we had a significant effect thanks to the diffusion of the active compound from the wall of the packaging to the food. In this case, it was a medium, a growth medium, so a solid medium. And then on the right, you can see the kinetics of release of LAE into different simulants. So we can, depending on the simulant and on the way of incorporation of active compounds, we can better design the release and achieve release levels and kinetics that are suitable for the specific food. Another strategy, going to the packaging related strategies now, is lightweighting, which is a universal strategy and should be assessed every time. So every packaging food system should be assessed in terms of optimization. Even if the weight of the packaging does not necessarily correspond to its actual environmental weight, a reduction in material can result in an environmental benefit, provided that shelf life is not shortened. So the beverage sector knows this strategy very well, since they have performed a significant reduction in the bottle weight in the last decades, almost 50% reduction in the carbonated soft drinks and mineral water bottle weight. This strategy is in line with the reversed pyramid of sustainability, where we find prevention and reduction at the top of the cone. So they are the most preferred strategies. And lightweighting, of course, is a way of reducing the use of packaging materials. Then we have the reuse strategy, which has been recently implemented or been proposed by the new regulation PPWR. The concept of reuse is complementary to the concept of recycling, because reuse means the thinking of new cycles of use for the same item, and does not imply the destruction of the item as it is in the recycling concept. Reuse looks very, very charming and very useful for sustainability purposes, but we have to look at some concerns on the feasibility. So I just want to discuss this theme of the feasibility, showing two examples taken from the Italian beer market. We have, in Italy, we have, as it is probably in many other countries, beer bottles with the different shapes, colors, and graphical items, which can be already present in the molds of the bottle. This helps, of course, the companies to promote their product and to create a linkage between the consumer and the product, to strengthen this relation. So marketing is very important in this case. But the second example is the German beer market, is taken from the German beer market, where you see again different colors and different graphics of the label, but the same bottle. This allows, of course, a system of reuse, the implementation of a system of reuse, because if we remove the label, the bottle will be the same and can be used by any, or reused by any of the producers, which is of course impossible in the Italian system at the moment. So the reuse concept involves some choices, very important and basic choices by producers, and it's not easy to implement. But another aspect linked to the reuse, in this case of plastic packaging, is some linked to some issues, technical issues, or health and safety concerns linked to the reuse of plastic packaging. Here I just show the highlights of a review paper on the topic. Plastic packaging reuse may affect the food hygienic, sensory and shelf life standards. The migration of sorbed aroma compounds may impact the sensory quality of beverages. The repeated use enhances migration of organic and inorganic chemicals. Reuse has the potential to increase the level of microplastic particles. And then the microbial biofilm colonization can limit the effectiveness of sanitization procedures. So these are all issues that should be taken into account when implementing a system of reuse for plastic packaging. I also want to draw your attention on the gap between the recycling rate and the presence of recyclate in plastic packaging. So the recycled content is one of the targets of the packaging and packaging waste regulation. I said before that by 2030, 30% of post-consumer recycled plastic should be included into new packaging, into new bottles. Data for the European Union show that 35% of post-consumer plastic is sent to recycling. So it's quite a good objective, good target, and it is increasing in the years. This is related to 2020. But on the other side, you see that the recycled content in new products is only 10% in was it in 2021. So why we recycle 35% of plastic, but we are able to include only 10% into new products? There are, of course, many technical aspects, especially related to the safety of use of recycled plastics into food contact packaging. So we cannot use any kind of recycled plastic, but recycled plastic can be used for specific applications, and within the food applications, to date, only PET is allowed to come into contact with food. So recycled PET can come into contact with food again. Other materials are under study, so some ongoing projects are assessing the feasibility of recycling for other materials such as polypropylene and polystyrene, which to date can be included in not in direct contact with the food, but in the middle layer of multi-layer packaging. So compostable packaging is probably one of the strategies that users and the distribution like most, because they recall the environment and the return of packaging to the environment through biodegradation. But the compostable packaging is not necessarily more sustainable. And to assess when compostable packaging can be suitable alternative to conventional plastic packaging, I propose these three criteria, let's say. So the alternative compostable packaging should replace a solution which has a critical end of life, should offer adequate performances, and should have demonstrated best environmental performances. So not always the compostable packaging alternative can answer all of these three criteria. And I want to show a first example which will explain why I didn't agree with linking PLA bottle with the concept of environmental sustainability as a driver for food packaging. There is in the Italian market one bottle for mineral water, which is made of compostable plastic. So it's a compostable bottle for mineral water. In the website, this is in Italian, of course, but it says that the bottle comes from the nature. It preserves the quality of water. You can drink it as usual. Then you should separate the cap from the bottle and then put the bottle in the organic fraction, in the organic bin. Then this bottle will become compost in 80 days, and then again you have a plant. There are some problems in this flow sheet because you cannot separate, you shouldn't separate the cap from the bottle. We have been taught to leave the cap attached to the bottle. This should be done because the cap is produced in a different material. So it's a conventional plastic compared to the bottle, which is bioplastic. And then the action to throw your bottle into the organic bin is a very strange action, I would say. And then finally, we have to know that when a rigid or semi-rigid plastic item reaches the composting facilities, these composting facilities will remove the rigid packaging, whether it is plastic or bioplastic, because not able, at least for the plants that I know, the system I know here in Italy, they are not able to recognize and to discriminate plastic from bioplastics. And also bioplastics have a longer degradation time compared to wet organic fractions. So if we want to answer the first question, replacing a solution with a critical end of life, I would say this criteria is not met, because by placing on the market a PLA bottle, we are replacing a PET bottle, which does not have a critical end of life. but is actually the most circular packaging or plastic packaging we have today. It's 100% recyclable and can return to food contact packaging again. Then for the adequate performances, probably yes, we can say yes, but for the environmental performances, I found some literature data that show that a PLA bottle performs worse compared to a regular PET. So if you see in this slide, the dark green data are the worst data. So PLA scores most of the for most of the impact categories the worst values compared to regular or recycled PET. So we cannot say that PLA bottle has better environmental performances, which was the criteria number 3. I think I should run to the end of my presentation because the time is running out. I wanted to present other 2 case studies which are more virtuous. So the replacement of the polyethylene layer in food contact paper, which in my opinion is more reasonable and feasible alternative, because it replaces, so by using bioplastic instead of polyethylene, we can then address this paper, which is usually contaminated with organic residues from meat or from foods, to the composting, while today paper, polyethylene coated paper has a critical end of life. This is well, an example of the surface of a base paper and a coated paper on the right. And the same for another project we have ongoing about the replacement for specific application of foamed polystyrene with foamed bioplastics, which allows the packaging which has absorbed exudates to be disposed of, or to be managed through composting. And for this reason, polystyrene absorbing trays cannot be recycled because they are contaminated by organic residues. So this answers the first criteria. Here we have a critical end of life, and it's reasonable to think of an alternative with compostable materials. So the key messages of today's lecture are: measures that save food can improve sustainability of the food chain. This especially goes for products with low prey. It is reasonable to replace a conventional packaging with a compostable one if the latter has a critical end of life, the alternative has adequate performances, and best environmental performance is proved. And finally, being certified as compostable is not to date a guarantee of real possibility of organic recycling. So we should take this into account when we think of replacing a traditional packaging with a compostable packaging. Before leaving space to your questions, I want to present this opportunity, this event. This is the 12th Shelf Life International Meeting, which will take place in Santiago de Compostela in Spain from the 8th of June to the 11th of June 2026. Early bird registrations and abstract oral presentations are possible until the end of February. You can visit this website, slim2026.gal, for more information and for the registration. And here you can find the different topics that are considered in the conference. So I hope to see some of you in Santiago de Compostela in June, and I thank you very much for your attention. So now I will try to activate your microphones and cameras for 10 minutes interaction.
Fabio, very interesting presentation. So let's see.
Thank you. I
About
will.
Questions.
Yeah, I will try to now.
I'll also check on the chat. Until now, there is no question.
Hi, Fabio. Many thanks for your presentation.
Hi, Tanya.
Was very interesting.
Thank you. Thank you.
I have a question. Maybe it's not. It's related to what you explained, but it's some question I make to myself, because we were talking about the green status of the plastics and the glass for food packaging, but you are talking about the industry. What about what we can do at home? Is it better to use plastics, glass, from your point of view?
Well, at home, I think that the reuse of glass bottles, for example, is much more feasible than at industrial level. So yes, I think glass is very welcome at home if we use it in this way, if we reuse it. For plastic, I suggest we shouldn't be very afraid of plastic, because it all depends on how plastic is managed. And fortunately, recycling systems in Europe are improving. So year after year, we have new plants which are authorized by the EFSA for recycling of food-grade plastics. So more and more plastic will return to the same use. So we will be really circular. Unfortunately, the world is very big. It's not just Europe. So what we are doing is not exactly what other countries or places in the world are doing. But I think we are going in the right direction. Thank you, Tanya. Probably we have a question in the chat.
Yes. From Celine.
Sustainable packaging using cornstarch has been studied for some time. What are your thoughts on its potential? Yeah, usually bioplastics made from starch, from renewable resources are promising, but the problem here is that there is an issue from the environmental point of view. That the issue is that we are dedicating cultivations to producing plastics, and this is actually the main criticism that was moved towards first generation bioplastics. Research is going forward and is especially considering now bioplastics that can be produced from residues or byproducts. So if we manage, as it seems it's possible, especially for polyhydroxyalkanoids, this will, I think, will give an important boost to the application of really green bioplastics. So we will not generate impacts by producing bioplastics, but we'll probably have alternative ways of using byproducts and the residues, especially from the agro industry. So at the moment, I think that packaging from cornstarch, for example, well, can be a solution, as I said before, for specific food applications where the conventional packaging raises some has some criticalities.
Fabio, just one question. So many times we see many products dealing with food that look like paper, but it's very but most of them, they have a cover of plastic, right?
Yeah.
So it's difficult for paper, for example, not to absorb food or not to absorb water or not to absorb fat. So when we are dealing surrounding a fatty product, even in fast food chains, it's not possible to completely substitute plastic, right?
Yes. This is exactly one of the case studies I showed very quickly at the end of my presentation.
Yes, the
So,
second one.
yeah, we wanted to address the replacement of plastic with bioplastic for specific applications such as fresh products wrapping or fast food application. So but in this case, it is hard to achieve the same performance of plastic with bioplastic because, for example, the fat, the resistance to fat or the resistance to moisture and to heat, and so vapor, water vapor is well, can damage very quickly the bioplastic coatings. So yeah, the paper. But if we succeed in formulating properly these layers of bioplastic to make an alternative, then we can address these materials to composting, because paper is compostable and remains biodegradable if we couple it with bioplastic. This is, I think, a challenge which makes sense to address. I think it's very important to focus on specific applications and find a reasonable alternative for specific applications.
Yeah, I think for me, the presentation gave me a different view of the plastics. But there's one more. You can check.
Can polyethylene derived from renewable sources be considered a better environmental solution even if it is not biodegradable? Okay, good point. Because I didn't say it, but most of you know that bioplastics can also be plastics that come from renewable resources but are not biodegradable, such as biopolyethylene, bio-PT, bio-PP. In this case, you can source the monomers from sugars, so from organic, from biomass. But again, it is the same problem as for starch. So you have to dedicate cultivations and land to the production of plastic. So it is quite. When we evaluate through the life cycle assessment the environmental impacts of a process, we also consider the land use. So in this case, I think we will not be able to demonstrate the better environmental performance due to the land use. The evaluation is very complex because we should take into account all the different impact categories, not just the global warming potential. And in this case, I think we will not succeed. I think recycling is really the frontier. So improving recycling, increasing the recycling, and managing to incorporate recycled content in new packaging is really the frontier here. Do you think that the incorporation of nanostructures and bioagents like chitosan or essential oils in food packaging will extend shelf life while reducing plastic waste? Surely the incorporation of active compounds can extend the shelf life. So this goes in the right direction for the prevention of food wastage. Reducing plastic waste is not exactly linked to the theme. And also the use of nanostructures can be a problem from a legal perspective. So we should consider the feasibility of incorporation of nanomaterials, which at the moment is very limited by legislation. So I think research should go on, but practical applications for nanostructures are quite limited today. But nanostructure, I think, can be very promising for increasing the performances of materials and so reducing the weight of the packaging. So achieving the same performances with lower weight. This is one of the main points of nanostructures. So we have recorded this session, and the recording will be available. So if any of you want to look again at some part, or yeah, you will be. This will be available to all of you.
All right. So I think we just need to thank you. Thank for your availability for this webinar, and thank all the participants. And we hope to see you again, the participants, in other webinars promoted by the Food Technology Research Group of UNIgreen.
Thank you. Thank you for the opportunity, and it was really a pleasure to share something with you. Sorry, and sorry for my voice today because I got a cold.
No problem. It was understandable, so very, very clear.
Okay, thank you.